Hello friends, this is question number 38 of year 2019 of IIT JAM Mathematical Statistics. Again, this is the question from limit theorems. So, this is the question based on central limit theorem. Let's see the question. A sequence of ID continuous random variable with this PDF is given as Sn is summation xi and x bar n is equal to Sn upon n also provided. And what is asked among these four options, which of the following sequence of random variable converges to normal distribution with mean 0 and finite variable? So actually this is the question from MSQ. So more than one options are correct here and we have to pick all the correct options. So to solve this question, we have to use the central limit. We have to apply the central limit theorem for Sn once and then we have to apply it for x bar n also. So let's see the solution. Given PDF is this one. Just make the substitution y is equal to x minus 1 upon. If you use this substitution, you will get this PDF. And this is the PDF of standard and this is the PDF of exponential distribution with parameter. Clearly here we get y follows exponential 2. Therefore expectation of y is 1 by 2 and variance of y will be 1. Next is this one, x bar n is equal to Sn upon n. Now to apply the central limit theorem for this Sn and x bar n, we have to find out the expectation of Sn and variance of expectation and variance for this Sn and x bar n. So expectation of Sn nothing but expectation of summation of xi, which is equals to summation of expectation of xi, which is nothing but n times expectation of xi. So to find out this, we have to find out the expectation of x. So from this substitution, what we have, y is equal to x minus 1 upon 2. So since y is equal to x minus 1 upon 2, so this implies x will be y plus 1 by 2. Okay. So now find out expectation of x and variance of x from this. This is the change of origin and scale. With the help of properties of mean and variance of change of origin and scale, easily find out the expectation of x and variance of x. So clearly expectation of x will be expectation of y plus 1 by 2. So expectation of y here it is 1 upon 2. 1 upon 2 plus 1 upon 2. Expectation of x is 1 here. Variance of x is there is no effect of change of origin on the variance. So we know this property. So variance of x will be variance of y itself. Variance of y is 1 by 4. Okay, now we just find out here the expectation of x and variance of x here. And now try to find out the expectation of Sn and the variance. So expectation of Sn is n into expectation of xi. Expectation of xi we just calculate this as 1. So expectation of Sn is n into 1 which is equals to n. So variance of Sn is again n into variance of xi. So n into variance of xi is 1 by 4. Therefore variance of Sn is n of 1. So now we have the values of expectation of Sn and variance of Sn. So use this the central limit. Okay. Now we will apply the central limit theorem for the sequence Sn. The central limit theorem is for whatever the sequence Sn minus expectation of xn divided by under root of variance of Sn follows normal chair one. So just plug the values here. Expectation of Sn is n and variance of Sn is 4. To solve this, you will get Sn minus n upon root n follows normal 0 comma, which is in the option A. That's why option A is the correct answer. Let's check for another option. Now apply this central limit theorem for another sequence x bar. As we know that if xi is any random variables, If expectation of xi is mu, then the expectation of x bar is again mu. So as the expectation of xi is 1, therefore expectation of x bar n is also 1 here. And the variance of x bar is sigma square upon n. So sigma square we calculated here at is 1 by 4. See here. The variance of x bar will be 1 upon 4n. So just put these values here. Solve this. You will get, if you take this under root 4n in the numerator side, you will get 2 root n x bar n minus 1 corresponds to normal 0 1 in distribution. So option C is the correct answer. So C is also correct answer, which is in the option C. So now if you to take this to this side, so root n into x bar n minus 1 corresponds to normal 0. This I did this, I read this form by mistakenly. Here it should be as here it is 2, so that's why 2 square is 4, so that 4 comes to be in the denominator. It should be 0 comma 1 by 4. Root n into x bar n minus 1 corresponds to normal 0 comma 1 by 4. So if you divide this quantity by 2, its square 4 to be multiply this side. So 4 into this 1 by 4, it should be 1. So root n into x bar n minus 1 upon 2 corresponds to normal 0 comma 1. It should be like this. But it is again the finite variance. See what is asked in the options. Which of the following sequence of random variable corresponds to normal distribution with mean 0 and finite variance? Okay. So we get option A is the correct, option C is also correct, and option D is also correct. So these three options, option A, C and D are the correct answer here. Okay. Thank you.